Welcome to Ask and Learn.
In this problem, we have this circular ring here, and we have a collar sliding on it, and there is a spring attached to the collar and then attached to ground. I find this as point B and use that as my reference point, my origin. We're told that the collar weighs 1 pound. The unstretched length of this spring here is 5 inches. The spring constant is 10 pounds per foot. The radius of this ring is 5 inches. We know point C here is 7 inches from point D in the horizontal direction. Point A is then 7 plus twice the radius is 17 inches from point D. And point B down here is 12 inches and then down 5. So we have that. So now we're told that the collar is at rest at point A here, and the spring is stretched because the distance from D to A, which is just the magnitude of A, is greater than 5 inches. And so we have some potential energy stored in the spring, and that's 1.7 foot-pounds. I'm going to measure this as my reference. So at the gravitational potential at A is 0. The kinetic energy at point B, which we're asked to find, or we're asked to find the velocity there, it has a kinetic energy given by this, and then the spring is again stretched at this point, so we can figure out the length of the spring is the magnitude of this vector. And now we've lost some potential energy because YB is now negative, so we have that from gravity. And so to figure out what the velocity B is, you know the kinetic energy at B, it must equal the difference in the kinetic energy at A and B, and that gives us a kinetic velocity of 14.3 feet per second. And so then we want to figure out what the normal force is as it passes through this point. So it's going this way, and we know that the acceleration is now going to be in towards the center, and that's in the positive y direction. So the mass times the acceleration is in the y direction is mvb squared over r. And then we have the normal force acting on the block. So we draw a little free body diagram of the block. We have gravity acting and then the normal force acting on it. And so we have gravity acting down, and we also have a spring force acting. I shouldn't forget to draw that, so somehow in this direction. So we have this, we have gravity, we have the normal from the ring, and then we have the spring force. And the spring force, its magnitude is K times spring constant times the change in length. And the direction is from B to D. And so we can figure this unit vector out because we know the position vectors of C and D, and then we can figure out what the y component of that is. So we can find FSBY, and we have everything in here then except for n, and we can solve for n, and that becomes 13.8 pounds.